In this next problem, we want to find the domain of a composition of functions, which is given by f of x is equal to the square root of x plus 2 times x minus 3 divided by x minus 1. And because square roots are only defined when the argument under the radical is non-negative, we need to determine when x plus 2 times x minus 3 divided by x minus 1 is greater than or equal to 0. Now the easiest way to do this is to sketch a graph of our function f of x. Let's call this g of x, which is our rational function x plus 2 times x minus 3 divided by x minus 1. So we'll have a vertical asymptote at x is equal to 1, and we'll have x-intercepts at x is equal to a negative 2 and x is equal to a negative 3. And furthermore, because the multiplicity of each of these x-intercepts is given by 1, then at these 2 points our graph is going to cross. So we can go ahead and sketch a picture of our graph. So this is a picture of g of x. And here we have a vertical asymptote here. Here we have an x-intercept and another x-intercept. So this one is negative 2, 0, and this one is positive 3, 0. So this should actually be a positive 3 here. So now let's plug in the value real fast. We'll look at g of 0. G of 0 is going to give us 2 times a negative 3 times a negative 1. And so this is going to be a positive 6. So at x is equal to 0, our y is equal to 6, which means the left-hand side of our graph is going to cross at the x-intercept negative 2, 0, go up to the y-intercept, and then keep going up. Again, let's choose another point somewhere in here. Let's evaluate our function at g of 2. So this is going to be 4 times a negative 1 divided by 1, which is a negative 4. So at 2, we'll go down 4, which means our graph is going to look something like this. And once it hits the x-axis, it's going to cross. So our function g of x is only positive when we have x values that are larger than 2, or negative 2. And it's also positive when we have x values that are larger than positive 3. So this interval here is given then by a negative 2, comma 1, where we don't include the 1, and this interval over here is given by the phrase 1 to infinity. So let me go ahead and rewrite the condition we're looking for. So again, we're trying to find where this inequality is greater than or equal to 0. And what we just showed was that our x values are greater than or equal to 0 when we have negative 2 to 1, where we don't include the 1, union 3 to infinity. And so this is going to be the domain of our function f of x. Let's look at one more problem of finding the inverse. And we want to find the inverse of the following quadratic, which is x squared minus 10x plus 2 on the domain x is greater than or equal to 5. So again, we're going to start off by rewriting our polynomial. This is going to be y is equal to x squared minus 10x plus 2. And we're going to switch all the x's and y's. So we'll get x is equal to a y squared minus 10y plus 2. And we want to solve for y. And we're going to do this in a little bit of a roundabout way. Subtract a 2 from both sides. So we'll get an x minus 2 is equal to y squared minus 10y. And now what we want to do is we want to complete the square. So add to both sides a plus negative b divided by 2a squared. In filling this in, we'll get x minus 2 plus a negative 10 divided by 2 times 1 raised to the second is equal to a y squared minus 10y plus, again, a negative 10 divided by 2 times 1 squared. So this simplifies to being x minus 2 plus 25. This is equal to a y squared minus 10y plus 25. And the right hand is going to factor to be a y minus 5 squared. So let's rewrite this last equation here. We get that this is going to be x plus 23 is equal to y minus 5 raised to the second. So take the square root of both sides and we'll get plus or minus the square root of x plus 23 is equal to a y minus 5. And what we end up with is y is equal to a 5 plus or minus the square root of x plus 23. Now again, we're on this restricted domain of x is greater than or equal to 5. So the domain of f of x is equal to the range of f inverse. And this function is going to be greater than or equal to 5 only when we choose this positive value here. So the inverse we're looking for is going to be y is equal to 5 plus the square root of x plus 23. And this would be the final answer.